In the fifth lecture video on momentum and collisions, we will use the impulse momentum theorem described in the last video to solve a problem. What force is required to slow a 48 slug car traveling 65 miles per hour to 35 miles per hour within 4 seconds? And how far does the car travel during its deceleration? Let's first write down everything that we know. We know the mass of the car is 48.0 slugs. We also know the final velocity is 35 miles per hour. However, in order to calculate the force, we need the velocity to have units of feet per second, so we will go through a quick unit conversion. We will write 35 miles as a fraction over 1 hour. Then we will convert miles to feet by using the conversion factor that 5,280 feet are in 1 mile. And then we will convert hours to seconds by using the conversion factor 1 hour is equal to 3,600 seconds. This gives us a final velocity of 51.3 feet per second. The initial velocity is 65 miles per hour, so we will need to convert this into feet per second as well. We will write 65 miles as a fraction over 1 hour and use the same conversion factors as before. 5,280 feet are equal to 1 mile, and 1 hour is equal to 3,600 seconds. This gives us an initial velocity of 95.3 feet per second. The other piece of information we are given in this problem is that the time it takes to slow down is 4.00 seconds. We are trying to find the force F. Our basic equation is essentially the impulse momentum theorem. Force times change in time equals mass times final velocity minus mass times initial velocity. We will rearrange this basic equation by dividing both sides by change in time to form the working equation force equals mass times final velocity minus mass times initial velocity, all divided by the change in time. Next, we can substitute in the data we are given into the working equation. Force is equal to 48.0 slugs times 51.3 feet per second minus 48 slugs times 95.3 feet per second, all divided by 4.00 seconds. When you calculate this, you should get a force of negative 528 slug feet per second squared. The unit of slug feet per second squared is the same thing as a pound, so our final answer is that the force required to slow down is negative 528 pounds. Your answer ends up being negative because there is a deceleration. The negative sign just indicates the direction the force is being applied. And this direction that the force is being applied is opposite the direction of motion. The other thing we need to find in this problem is how far this car travels during its deceleration. This part of the problem is a good review of topics covered in the accelerated motion chapter, as we will be using an accelerated motion equation to solve this. Since we know initial and final velocity as well as the time, and we are trying to solve for the distance s, we will use the basic equation s equals 1/2 the sum of final velocity plus initial velocity multiplied by time. This is the same thing as thinking that we can take the average velocity multiplied by time to get the distance traveled. Since this equation is already written in terms of s, all we need to do now is substitute. S equals 1/2 the sum of 51.3 feet per second plus 95.3 feet per second times 4.00 seconds. This gives us a distance traveled during these 4 seconds of 293 feet. This concludes our discussion and examples on the impulse momentum theorem.